As promised, guys, imagine you have a section like this. Never mind whether the section is what is the section, never mind that. We want to work out the centroid for that section. For this exercise, I will show you how to work out x left, x right, y upper and y lower, all of them, just to get the position of the centroid. I'm going to start off by showing you how to calculate y lower and y upper. So trying to find the position of the x-axis. Okay, first thing first, I divide my section into subsections. So I'm going to call that, so the big one, I'm going to call it area 1 or zone 1. The second one, area 2 or zone 3. This is an opening, can be a pipe for services with a diameter of 75 millimeter. I'm going to call it area 3. Luckily for this section, I like it, we've got all possible shapes that we can get for this course. So first things first, I'm going to calculate my areas. What is area 1? This is 100 plus that is 260 times the height is 500. 3 plus 2 is 500. Area 2, remember, it's a triangular shape. Area half base times height. Remember, guys, I am still using this. I'm using this to get the area is half base times height of a triangle. That one is length is b times d. I'm using this, guys, in case you're wondering where I'm getting all this. Okay, half times my base is 260. The base, which is the distance from there to there, but my height is 150. I'll go to area 3. Remember, area 3 is an opening, so it's a minus area. I said when I was explaining this, if you're using the diameter, your area is pi d squared over 4. If you're using the radius, your area is pi r squared. Same with that. And there is nothing stopping you from dividing that 75 into radius. So the radius is the distance from the center to anywhere in that circumference. It must be from the center. So the radius here, if you like, is 37,5. I'm just saying 5 divided by 2 is 37,5. So the radius is 37,5. So it's up to you. You can use the diameter, you can use the radius, but what is important is a minus area, because that area is not there, it's an opening there. Okay, I'm gonna use pi times my d is 75 squared over pi d squared over 4. I'm using the full diameter, but remember, another student can use the radius here, the radius. So that means it's going to say pi r squared, r being half of that. Okay, so total, I'm done with my areas now. So calculate my areas. 260 times 500 is 130,000 square millimeter. I don't like working with those values. 130 times 10 to the power 3 millimeter squared. It's the same thing, guys. Here, half times the base is 260 and the height is 150. Even if I've got some of the answers wrong, guys, when I'm punching my calculator, remember, the most important thing here is the concept. I'm showing you the concept. 195,000. So 19,500. which is 19,5 times 10 to the power 3 millimeter to the power 2. Here is pi, second function pi times 75 squared divided by 4, and that gives me 4417.86 millimeter squared. If you convert it, then that gives you, remember it's negative 4,418, doesn't matter, times 10 to the power 3 millimeter squared. Okay, remember the difference of 0, something is not going to make any difference. And then the total area, I'm adding these two, I'm subtracting that one. 130 minus 19.5 minus 130 plus 19.5 minus 4.418. That gives me 145.08 times 10 to the power 3. That is my total area. That is my total area. You add the two, you subtract that. Okay, fine. Now I'm going to calculate y lower. I'm coming from the bottom, from there, from that level. Coming from this level to the centroid. I want to know what is the distance from this level to the center of my section. So y lower, that is my x bar, but considering y lower is equal to area 1 times x1 times y1, sorry, because I'm measuring along the y-axis, plus area 2 times y2 minus area 3 times y3 divided by the what? A total. Okay, what is area 1? Okay, area 1, there's area 1. 130 times 10 to the power 3 times, what is y1? Remember, you're looking at this now, ignoring everything else, but you're looking at this area 1. I know that for area 1, it must be d over 2, the distance from there to the center of area 1. Without that, the distance from the bottom to the center of area 1 must be this height of area 1 divided by 2. What is this height? Is 3 plus 2, which is 500. 500 divided by 2 is what? Is 250. That is my y1. Plus, I go to area 2. There's area 2 there. 19,5 times 10 to the power 3. And then times. What is the distance from the bottom to the center of area 2? Remember, there's area 2 there. The center of area 2, we were told there, that distance there is 1/3 of the height. This is the distance that I want. I want to know what is the distance. The 1/3 of the height is going to take you there. But I'm not taking moments about that point. Can you see now I'm using the language moments? I'm taking moments about this point now. So the distance must be from the center to there. So 1/3 of h, I'm going to write it down so that you can see it. This is, as a third of h is 150 divided by 3. That is 1/3 of h plus 1/3 of h is going to take me there, but I am not looking from the distance from there. I'm looking for the distance from there all the way to there. Therefore, I must add this distance, the bottom distance, this one, plus 500. Then minus. Why am I minusing now? Minus because I'm subtracting the area. Is that right? The area is 4,418 4,418 times 10 to the power 3 times, what is the distance? The distance is given, guys. You are told there that the distance from the bottom to there is 200, to the center of that area is 200. Then you divide that by the total area. What is the total area? 145,08 times 10 to the power 3. Then you've got a distance from the bottom to the center of the area, the combined area, not the center of this area or the center of that area or the center of that. Your distance is from the bottom to the center of the combined area. Okay, so you can punch your calculator and get that distance. So I'm now going to show you the distance from the top now. Again, I know area 1 is this 130 times 10 to the power 3 times, what is the distance? Remember the top now. Which part is the top? This is the top. This is the top, the highest point in that area. So I want the distance from the center of from the top, far top, to the center of this area. I know that distance from there to there is 250 because it's half of 500. Is that right? From the center to there is 250, but I must add 150 because I want the distance to the far top. So I'm taking moments about the top. So it's 250 plus 150, 400. So I'm using the same formula but coming from the top now. Same formula but coming from the top. Plus I go to area 2. Area 2 is this one. There's area 2 is 19,5 times 10 to the power 3 times the distance. Remember now I want this distance now. This distance from the center to there, of which that distance, we want this distance now, this distance, of which that distance we were told that is 2 all over 3 h, our h being 150. So is 2 all over 3 times the height is 150. So this is my x's. These are my y1, y2 and y3. Okay, these are my distances. This is the area, this is the distance. This is the area, this is a separate 4,418 times 10 to the power 3 times. Now I want the distance from the center of this area to the far top. From there to there is 300 is given, and then I add that 150. So that gives me 450. I divide that by the total area. Then you've got your answer. I divide that by the total. Remember, your y lower combined with your y upper must give you the full height if you're on the right track. Your y lower and your y upper must give you that total height. Then you will know that you are on the right track. Even if there's something wrong, then you are able to say, yes, I'm wrong, but at least I can get method marks because the method is correct. Unfortunately, guys, you can punch your calculator and get all those distances. And confirm whether your y lower combined with your y upper is giving you the distance. So y lower is going to be the distance from the bottom to where you've got your x. Let me quickly punch it on my calculator. 130 250 plus 19.5, that's 3 times, open brackets, 150 divide by 3, that's 500. I hope it's right. Minus 4.418 exponent 3 times 200 divide by 145,08 exponent 3. I'm getting 291,85 millimeter from the bottom. I'm gonna try the top 130. Getting 358,16 millimeters. And I think there's a problem here. 291.85 plus 358.16. I think there's a problem here. So it's 650,01. Let's see here. 650. Yeah, that's perfect. If you add that and that is giving you 650,01. Remember, there's round offing, guys. That is going to work up. If you add this dimension y lower and y upper, then you've got 650. So 290, this is 200, 291, this is 200, somewhere there. Somewhere there. Not, you don't know exactly, guys. That's the position of x. From x, from the top is 351. Can you see? Y upper there is 358, 358,16 or 15. Just say 16 or 15. It doesn't matter. This side here is 291,85. 291,85. That is the position of x. I know the position of x. From the bottom is that distance. Remember, when you punch your calculator, maybe you will be more accurate because I was rushing. You'll be more accurate. Now I want x left and x right. Same approach. Okay. X left is equal to area 1 is not going to change, 130 times 10 to the power 3 times what is the distance of that? What is the distance from, sorry guys, what is the distance from there to the center of the rectangular shape? So it's 100 plus 160, which is 260. What is half of 260? Because it should be b over 2. Half of 260 is 130. There's no 130. Let me just take out this. So guys, times 130 plus 19,5 times 10 to the power 3 times what is the distance? Okay, because we're taking moments about this far end now, x left. What is the distance from there to the center of this area? Is 2/3 of b. Is 2/3 of this dimension. 2/3 is 2 all over 3 times 260 minus 4,418 times 10 to the power 3 times, remember area 3, remember area 3 is 4,4175. That's the round offing I was referring to. And then times the distance is given. The distance is given from the center to there, to the far left is 100. And then you divide that by the total area. Did I calculate the total area again? No, I did not. I didn't calculate the total area again. It's the same. Did I calculate the areas again? No. The only difference, the distance is now, because you're coming from the different axes. Then you divide by 145,08. then you've got that. Then I'm going to calculate x right. 130 times 10 to the power 3 times, and then 19,5 times 10 to the power 3 times, and then minus 4,418 times 10 to the power 3 times, divide by the total area 145,08 times 10 to the power 3. Okay, now I'm working x right now, meaning I'm coming from which side? From the right hand side now. I'm coming from the right hand side now. I'm coming from the right hand side. So the distance from the right to the center of area 1, there's area 1, remember? The distance from right to center of area 1 is still the same because it's this dimension divided by 2. From there to the center is 130. I'm just filling in the gaps now, if you're looking there. Then I come to this one. The distance from the right to the center of this area is 1/3 of 260. It's 1/3 times 260. Okay? The distance from the right to the center of this area is given there as 160. Then you get your x left and x right. So I'm gonna calculate it first for you guys. So, 130, that's 1 times 130 plus 19.5 times minus 4.418 3 times divide by and 3. Here I'm getting 136,74 millimeters. Then I go to the next one. Plus here I'm getting 123,26. If I add the two, 123.26 plus 136,74 should give me why is it giving me 263? Something is not right. Already I can see that I did something wrong there. I don't know from where. This is area 3. From the left, yes, is correct. From the right is that. Then 2/3 of 160 from the left, and then 1/3 of 260, and then 1/3. I think it's just punching of calculators. Otherwise, 136,74 plus 123,26. That's 260. I don't know what I'm doing. It's 260. So x left plus x right is 260, which is the same dimension as that dimension. That's how you calculate the centroid of the section. So if we're measuring now, they said from the left it must be from the right 123. This is 160. 123 maybe somewhere there. This is y, guys. That distance from the right is 123,26. From the left is 136,74. From the right is 123,26 from right to y axis. But from left to y axis is 136,74. Now you've calculated the centroid. There's your centroid there. That is the center of that area. That's the most important area. But I will explain it to you why the centroid is important. Why do we need to know the centroid? More especially when you are calculating the bending stresses. It's very important. I hope you enjoyed today's video, guys. Go through it, take your time, pause it, try and see what I'm doing, redo it after that without looking at the video. If you have problems from this, that means you're going to have problems again in the next one. Rather, you don't start doing any tutorial questions, you ask questions now. Don't jump to a tutorial question before you can do this yourself. You must do this yourself without looking at a video. Then you will know whether you're on right track, and then you can attempt the tutorial questions. I hope you enjoyed, guys, the video. Thank you very much. Bye, guys.